Hello, everyone. Welcome to Expert Talks Online. If this is your first time with us ever, welcome. Equal Experts is a software consultancy, and one of our passions is to make sure that we give back to the community by running these sorts of events worldwide. I'm Tony Ewan. I'm the Transformation and Delivery Principal for APAC, and I'm going to be hosting you this evening. Our speaker tonight is Nick Williams. Nick's been an Equal Experts Associate for almost 4 years, Nick. Is that right?
Yeah, something around there. Yep.
The majority of that time, he was in our UK office with some of our large public sector engagements. More recently, he's joined us for a tour of duty in Australia, helping one of our retail clients, and is currently sitting somewhere up in Brisbane, sunning himself. Today, Nick is going to talk through the intricacies of testing infrastructure as code, and then some of the key considerations that you need to take into account. We'll have some Q&A time at the end, so if you have a question, please use the Q&A panel, and we'll cover them before we wrap up. On that note, I'm going to hand over to you, Nick.
Awesome. Thanks very much, Tony. Yeah, thanks for coming, everyone. We'll dive right in. As Tony says, I'm Nick Williams. Worked with you for a few years now. What we're going to talk about today is testing infrastructure as code at scale. Specifically, how we worked with a large government department in the UK in this instance on a data and digital platform team. And the approaches that we took to make sure our services were up and running, and how we could deliver a good platform to our users. For a sense of scale, that I was a tech lead on a platform team at this government department. The platform itself consisted of probably a few hundred developers, data scientists, architects working on the platform itself, which supported services which were, some were sort of citizen facing, you'd have to use it to do your taxes every year. Some were analytics used by various government departments about learning about citizens and how what they need, what rights they have, and all sorts of detailed information which I never got to see because I was just doing the platforming stuff. When I say the platforming stuff, from a technology point of view, these were our big five that we were using. So PowerShell, Terraform, Ansible, Docker, Packer, Kubernetes. There's a lot of other things mixed in there, but technology-wise, these were the big five that we were using and the stuff that we wanted to test coverage over. In terms of what we were actually using those tools to build, it was reasonably varied, and we had various problems in delivering different sorts of things. So try to break down into these four. So as a service capabilities, what I mean by that is we would deliver in the same way that you might consume a service from AWS, like I want some EC2, or I want to set up, I use an RDS instance. You might think of consuming those services from our platform. So I want a Hadoop cluster as a service, or I want a logging and monitoring stack, which I just consume as a tenant of. And I'll pull it from the platform which we've built. I can start using it. It's security approved, hardened, ready to go. That was one sort of deliverable that we'd sort of produced. Other than that, usable modules we did a lot. So our as a service capabilities tend to multi-tenant solutions. So you sign up for a tenancy and be able to start using that service. For some of the products that were being built on the platform, they needed to be really highly isolated. They'd need to run their own infrastructure completely, their own stack, at which point they're consuming some of our modules, which would be things like Terraform modules, Ansible roles, which again, they're very opinionated, they've been security approved, where they work in the way they need to work, try and produce some paved roads for teams getting set up. Base images were a big thing that we had to do. This sort of feeds into that paved road, whereby we had a very locked down security environment. So even from our environments where we perform builds, like building Docker images or building applications, there'd be no internet access. Everything has to be over TLS. Everything needs to be patched regularly, which if you're a brand new developer coming into an environment and you just want to install some NuGet packages in your Docker image is quite a lot to learn when you can't just pull it from NPM website. Beyond that, we'd also run a lot of commercial off-the-shelf products. So these were things like data virtualization tools, scheduling tools, which are consumed across, tens of teams. And we'd run those services. We'd install and run those services. The problems that we were seeing time and time again with delivering these things fell into these sorts of categories. So particularly with the reusable components and with the as a service capabilities, we found it really difficult that we had no clear way to define an interface for the infrastructure that we were using. So obviously, if you're running a Terraform module, you've written a Terraform module, you'd definitely be able to define the interface of how to consume that module, but there's so many side effects when you're actually deploying that infrastructure that people then run things on. So if we take, for example, an EC2 instance, which someone may run, say, a web app on, that was something that we did fairly regularly. The problem that we would have, there's so much around the EC2 instance that could change. What can I connect to from a network point of view? What tools are installed in the AMI by default? What do I need to install myself? And there's no clear way to say this is what we're expecting to work and these things are just byproducts. That led to us often releasing a lot of unexpected breaking changes. So maybe we would do, perhaps you could take the example where no one should ever have been contacting some external DNS service, but because of either a bug or we'd missed it in the requirements, some services were depending on that. We'd turn it off thinking it's a great security fix. And then we've broken a bunch of applications that were dependent on a particular networking route. And we'd have no way to know about that or communicate it with our customers. With a lot of the services we were deploying as well, because we were a platform team, sort of a little bit isolated, which is probably a conversation for a different time. We found it really difficult, if not impossible, to dog food a lot of the tools that we were building. So when we're deploying a big data virtualization tool, we had no need to consume that. So we weren't in there every day understanding how it worked and feeling what was good and what was bad, so we could improve the product, because we just weren't those people. And we found it really hard to get feedback from the consumers of those tools. For the COTS products in particular, a lot of them were not chosen by our team. They were chosen by the people who need them, which kind of makes a lot of sense. But none of us were experts in the product themselves. We'd have to rely on vendor support, which was great. But when you're not in the mix of building on and in the environment that we're allowed to use, we often couldn't follow the suggested patterns of deploying, because they use services that were unavailable to us, which led to a lot of issues around potential issues around security, availability, and regression. Overall, what that really meant was once we'd got something working, there was a lot of fear of making any change to it. So fear of making a change to a service or a component and the way it works, fear of then deploying it even once we've tested it really well, fear we're going to cause an outage, which ultimately led to really slow and infrequent releases, particularly into production. So it took a really long time for changes to get there, happened infrequently, and we wanted to fix that. We took a few approaches to how we might look at fixing that. One of the ones which I think really made the biggest difference was our approach to how we were doing testing, which is what we're going to talk about today. So hopefully that set the scene a little bit, and let's dive into some detail. So we broadly broke down our types of tests into 4 different tests. Static analysis, functional tests, smoke tests, and monitoring. We'll look through each of these, and we'll go through a little demo soon in what we mean of each of these and show that working. I don't know if anyone's ever gone down the road of having fully automated functional tests for infrastructure as code before. Speaking personally, I'm from a more dev background than an infrastructure background. So kind of working in a test-driven development way is really how my brain works these days. Trying to isolate yourself from the outside world when you're writing unit tests and all that sort of stuff is great when you're writing application code. It becomes difficult when you're writing infrastructure code. One of the main problems with that is, I'd argue at least 99%, if not more, of infrastructure code is normally communicating with something else. So AWS, Azure, GCP, or a Kubernetes cluster, whatever it is, it's not something that's just internal. You got to talk to something else. We looked at various approaches on how we could abstract that away. AWS and Azure give you some tools to be able to do this, so you can kind of run an Azure stack locally or the equivalent in AWS. We found it was not at all comparable to how we were actually deploying things, and it wasn't giving us any sort of real coverage over what we were trying to test, which basically meant we had to find a way that we could communicate with the outside world, test the real thing that we're going to deploy in the way we're going to deploy it, and make ourselves happy that it's going to work. The other problem compared to sort of application code is functional tests take a really long time in infrastructure land compared to some unit tests, right? If you're spinning up, say, an AWS RDS instance, you're probably going to be waiting for 20 minutes for it to spin up at least. Then you might realize you've got some settings in the parameter group wrong, and you need to rebuild the whole thing. So now you're waiting another 20 minutes as you're doing your development. So that whole TDD cycle is really hard to get working. And we'll look at some approaches that we took to fix that soon. If you scale that up from deploying a single module to running a bunch of modules together, which we might call an integration test, or even an end-to-end test of your entire infrastructure, you're up to that taking many, many hours, probably all day. And once you get into that, tests taking hours and days, you get into a real problem with flaky tests. So if you were trying to deploy an awful lot of infrastructure at once, we found that tests were just way too flaky. So I don't have an exact number for this, but I'd say on average, probably in AWS, it might be fair to say that every deployment you do of, say, an EC2 instance, a database, whatever, maybe has a 1 in 1,000 chance of some random intermittent error. When you're only deploying a few of them, you can work around that with retries and replays and other such circuit breakers and stuff if needed. If you're deploying a whole stack of many resources, the more resources you deploy, the more chance you get in, the more chance you have of getting failures, and you kind of have to stop and take a reapproach, which again we'll look at. One of the other things, once we got this working, which we missed out on our first iteration, and we'll talk about this later, is the runaway costs. So if we're saying that our tests have to talk to the outside world, they have to create real infrastructure in the way we expect it will do in a production environment, we're going to spin up real infrastructure, which costs money. So we have to make sure we clean up for ourselves and tear everything down properly and in a timely manner. So probably enough talking from me for right now. So let's go through a little demo of how we might structure these tests, how they might look and how they might run. I'm going to go through a really simple demo. Hopefully it's easy enough to follow. What we're going to build is this little diagram on the right. So we're going to do this in Kubernetes just because it's easy for me to run locally without having to make sure that AWS don't have any issues right when I'm going to do this demo. We'll set this up in a way where what we're going to try and do is deploy and configure a Kubernetes namespace to allow some ingress into a web service, and it's going to allow some egress to, in this case, Google's DNS, and it's going to deny any egress to anywhere else, right? So reasonably simple, pretty run-of-the-mill. We don't need to spend much time trying to understand the code that actually configures Kubernetes. We're much more interested in the tests. So we'll run through that now. And when I say we don't need to care too much about the code that actually configures the Kubernetes namespace, I don't even think we need to look at it. This is what we will have on the go. So I've got two Helm charts. Ingress Nginx is just a regular Helm chart. That's got it off online. This is Google's Ingress Nginx chart. Namespace baseline is just another Helm chart, which is going to do the network policies to allow us out to Google and denies to everything else. And then we've got some sample service which I can deploy so that I can test that all the ingress and stuff is working. So the first sets of tests that we come to is all our static analysis tests. I would guess that of the people listening, if you already work in and around IaC, you've probably got some static analysis going on already. If not, it's a really easy thing to pick a tool and start using it. There's a bunch of tools available. I've thrown some up on this slide here. There's way more available. In our case, we mainly use Chekhov, which covered all of our Terraform and all of our Kubernetes manifests and Ansible roles. The key thing that static analysis is doing for us is it's not going to deploy anything. It's just going to scan our code and look for suspicious patterns. So common security problems, common operability problems, which you can tell just from our declarative infrastructure as code. I think it would be hard to choose a tool and get it wrong. The reason that we went with Chekhov is we had a lot of people who were pretty good with Python, and Chekhov lets you author your own rules for scanning either Terraform code or Kubernetes or whatever it be, Python, and share them across your whole team. So if we found that we were constantly seeing problems with, let's say, security groups not being named properly, didn't adhere to our naming policies, we could easily knock together a little static analysis check for that, run it against whatever repos we wanted to, probably as part of a pipeline ultimately, and get a really quick feedback, which was great for when we were onboarding new developers. It makes it really hard for them to make mistakes and to get feedback really quickly. And the key thing with your static analysis tests is they are really, really fast. You're looking in the order of a few milliseconds and you get reasonably good results back on that. It saves you having to try and do a deployment and things failing, particularly in our case where, as we went higher up the production, the stack up to production, there was every now and then a few rules that weren't, which were only there for production type environments, which is really annoying when you've tested everything in sort of a lower environment, and it turns out there's some changes which we can kind of wrap up in static analysis checks. So if we have a quick run of this for our Kubernetes demo, we can have a quick look at the output and we'll look through it. So let's do a run of a lint. So what I'm doing here is just running Chekhov, which is going to look over all of our Helm charts for us. And bear in mind, I've pulled these off the internet. I haven't changed them for the Ingress Nginx Helm chart anyway. And it's found a bunch of potential problems. And you'll see I haven't had to author any of these checks. I've just opted into the Chekhov maintain checks, and I've got literally hundreds of tests that are being run against my code now. Some of them you might want to opt out of. So, long code lines like we're seeing here, maybe you don't care about that. Maybe you can opt out of this, but it's found some really cool things around how this is using the cluster roles. Like maybe we could make this a little bit more least privilege. All sorts of things that if I'm authoring either a Terraform module or a Kubernetes manifest, I'm likely to miss because I'm thinking about the functionality of what I want it to do and not the in-depth detail of exactly how I'm doing it. It's a really nice, quick safeguard. You see how it's just running real time there, which lets you fix things really quickly, really fast feedback. So I think that that's worthwhile doing. It's not going to capture everything, but it's super quick, super easy to just pick a static analysis tool, start running it against your code. So let's move on to something a little more interesting. Talk a little bit before we jump into the code about what functional tests are and how we go about them. So with functional tests, we are, as you might imagine, trying to figure out whether our module, our piece of infrastructure, our service that we're delivering is doing all the things that we want it to do. Is it functioning properly? There's a few approaches to that, and we had in this cover department, which we're talking about at the moment, we had some tests, automated tests already running using tools like InSpec and GOS. The way that those tool works is you're able to sort of declare, I think that these settings should be set on my infrastructure. I think things should behave, should look like this. What I mean by that is, if you imagine what would be a good example? Let's say for an RDS instance, you need to have TLS enabled, right, and enforced. That's a fairly common requirement. You should probably have that. If you were testing that sort of functionality in InSpec and GOS, you would probably write a test that says, look at the parameter group of my RDS instance, check that the TLS setting is turned on, and if it is, pass; if it isn't, fail. Now, that is some value into that. The problem that we found is it's too easy to make a mistake in your test, because your tests look a lot like your code. So if you're using things like Terraform or Helm or even CloudFormation, you're already writing very declarative code where you will have a line that looks something like, make sure TLS is turned on, true. Having a test that then looks almost exactly the same, your tests almost become a copy of your code that you're trying to deploy, and you're not really seeing how your service is behaving. You're just checking all the settings where as you thought they'd be set. What we found was a much better approach was to really exercise the function and see it behaves in the way that you want it to behave, as opposed to checking all the parameters are set in the way that you think they'd be. So I've thrown up a few examples here. So if you were running a web service, something over HTTP, you might validate it by sending HTTP requests in, making sure you get 200s back you expect them, requiring authorization where you expect them. If you're just deploying a server, you're probably going to use something like SSH commands to SSH in, check that whatever scripts maybe are on there or whatever tools you've installed are available. And we can go for, that goes the same for cloud services, databases, container instances. So I think the key part of this is that when we're doing functional tests, we found it was far better to be testing, does this service behave in the way that I want it to do, rather than are all the settings like I think they should be, which was a big problem that we had for a period of time. We'll have a quick look now at how these functional tests might look. In this instance, because it is what we did, and I think it's a really cool tool, we're going to use a library called TerraTest. It's probably wrong to call it a tool. It's actually just a Go library. So we'll be writing codes in Golang. If you don't know Go, don't worry about it. They're not that complicated. I'll talk through how the code looks. It's pretty easy to pick up, and the theory is way more important than the actual tool being used. The reason we went with TerraTest itself is it's really just a bunch of helper methods around common infrastructure tools and use cases. So it gives you really nice, almost sort of one method entry points to, I want to get a private IP of an instance in an auto-scaling group. I want to exec something on a running container, which if you write that code by hand using, say, the AWS SDK, you end up with an awful lot rather than a little really helpful method. So let's take a look at that. So the key that we found here when starting to write tests, as I said, coming from a development background, I was very much in the TDD mindset, as a lot of the team were. The problem we found with trying to do TDD in its purest form, where we write one test, we see it fail, we then try to write the minimal amount of code to make that test pass, and then we move on to the next one. Trying to work in that way with infrastructure meant that we were rebuilding infrastructure really frequently, which is where those really long lag time comes in. So your feedback loop as a developer was really long. And we wanted to try and get away from that, because obviously we don't want to just sit around for 15 minutes while an EC2 instance gets rebooted and rebuilt, or an AMI does. What we found worked really well was taking more of a test first approach, where we could kind of write out all of our tests, either with content in or with, as we've got here, just failing tests, which would kind of let you get to the point where you understand the whole thing that you need to build, and you have a good stab at writing your infrastructure code to make all of these tests pass first time, and then you can iterate on what you've missed and what you've what's failing. So if we have a quick look at this, you can see hopefully it's reasonably explanatory. We can describe a particular function that we want our service or infrastructure that we're deploying to perform. So here I've got a block where I'm going to be able to set up some HTTP services, tests, and some block where I'm describing how the network access should work. So we should allow access to Google DNS. We should not allow access to Cloudflare DNS, for an example, which is how we want this to ultimately set up. The next thing we need once we've got some of our tests written down, even though at the moment they're all just set to fail, is to have a little bit of a test harness, which lets us deploy our infrastructure, run our tests, make changes, redeploy the infrastructure, maybe tear it down. For that, we had this fairly generic test handler. So if we have a look through this, the top two lines are just a bit of Go test setup. We then had these little feature flags, which we used environment variables for, to say, do you want me to perform a destroy? So that might be a Terraform destroy, might be a Helm on install, whatever we implement in this destroy method. Do you want me to run an apply? If so, run the apply, and we'll take a look at the code that we put in the apply soon. So that would be, maybe a Terraform apply, it might be a Helm install, that sort of stuff. And then do you want me to actually run your tests? At which point we'd run our test specs. We'd be able to configure a slow spec threshold, which gets pushed out a lot more than if you're just writing unit tests. So you put an hour in here, just so it doesn't tell me, hey, your tests seem to have taken a long time, because if you're deploying a database, they will do. And then we'll have all of those specs that we've just looked at, which they're going to run through and run the checks for us. So what might an apply look like? So if we think back to our demo where we've got a couple of Helm charts and a Kubernetes manifest that we want to deploy for a service, if I were testing this myself by hand, I might just from the CLI run Helm install, point it to the chart, Helm install, point it to that chart, kubectl apply, point it to my service file. And this is exactly what our QAs and I as a developer was doing before we tried to automate any of this. And what we're seeing here is bits from the Teratest library. And the thing that we found really good about it is the way you interact with it, as much as it's in an automated test now, it really feels like you're just doing the same things that you'd always done from the CLI. So you see here, I'm calling a Helm install of the ingress chart, which this is a path to the ingress chart. And I'm able to pass through some set values like I always would do from the CLI. Similarly, I'm doing a Helm install for baseline, and I'm doing a kubectl apply. So hopefully that makes some sense, and it looks a lot like you'd write from the CLI. And when I say it looks like what you would write from the CLI, I think you'll hopefully be able to see. Excuse me. Hopefully you'll be able to see that it really does look just like the CLI. So if we run this converge, you'll see we get a bunch of output, and this is the same sort of output that you get if you ran these commands from the CLI, because that's exactly what's happened. You see here the output saying that we're running a Helm install with a bunch of arguments, and here's my Helm output. Post install, we're running another one, we're in the kubectl apply, and here's the output from my kubectl apply, right? So this is exactly the same thing that we've all probably always been doing, running it just from the CLI, but except now we've got it wrapped up in some automated tests. So at that point, I'm able to automatically deploy my infrastructure, and I can start authoring all of my tests. So one of those things we wanted to check worked in our example was I should be able to send a HTTP request via some ingress controller and get a response back. So rather than checking, is the ingress controller installed? Is it running? Is it showing as ready? Let's just send a HTTP request in and see if it works. So here I've added a new test, which is saying the HTTP services should be able to invoke a web service. You see I'm calling this HTTP get with retry custom validation. We'll talk about retries in a little bit. But effectively, we're literally just making a HTTP request to the service where it should be served from, and we're checking that we're getting a 200 back and that the string contains a particular message, which is hello from hello world. If I wanted to run that check, again, we could just run the test. In this case, I'll just run the HTTP services because we haven't got any code for the other test yet. If we see this come through, then we should see that it's just run the tests here. It's not touched any infrastructure. It's not redeployed anything. It's run our tests. Yes, we've got a HTTP response back. It was 200, so everything looks good, which is pretty cool. Then that's kind of, the ingress HTTP, test a HTTP first service with HTTP sort of fits in with our testing philosophy of test the solution performs in the way you expect it to. What gets a little bit more tricky is, well, we want to check that pods are able to resolve DNS from Google, but we want to check that they can't from Cloudflare. So how do you do that? There's a bunch of options for this. What we found was the easiest way, and I've cheated here because you can see I'm using a ping rather than actually doing DNS resolution, but using something like TerraTest again, we're able to do a kubectl run command. And this is exactly the same as if you were on the CLI doing kubectl run. I'm asking it to spin up an Alpine container, and I'm saying run the command ping Google, ping 8888. And then similarly for Cloudflare, I'm saying run a different Alpine container, name it something different, and ping Cloudflare. And I'm checking that that works in the case of Google. I'm checking that it didn't work in the case of Cloudflare. So this is letting me, again, do the same things that our QAs and myself would have been doing by hand, but now it's all automated. It's written down, easy to throw in a pipeline. So I could rerun a verify here, and we'd see these tests run. What I'll do instead is run a slightly different command that we had, which was test. So rather than just running the tests, which is what happens when we run verify, in our case, when we run test, what we'll do is we'll have the code clean up all existing infrastructure, redeploy it all, run all our tests, check for idempotency, and then tear it all down once it's succeeded. Which, if we have a look at that, and I'll explain why we need these sorts of different loops in a moment. So let's have a look at the output here. So we're running our test. It's started here, cleaning up, doing all the uninstalls. It's come through, it's reinstalled everything. And if we have a look here, we can see that our test is currently looking like it's hanging. And you see here, we actually got an error saying that HTTP GET returned an error, which is kind of what we expect, right? Because doing a Helm install is an asynchronous task if we're not waiting. We've deployed our ingress controllers and all the configs there, but we'll wait. Under the hood, Kubernetes is still spinning them up. They're waiting for them to be ready. So that's why we need to make sure whenever we're writing these tests, we've got retries in place. We're ready to handle flakiness, and we're able to handle things being asynchronous, because that happens an awful lot when you're deploying infrastructure, right? You kind of declare, I want the state of the world to look like this, and there's going to be some sort of lag time until that's really taken effect. So you should be able to see here, hopefully we've got a bunch of errors. Timeout has exceeded, and then eventually we've got a pass where the Kubernetes controllers must have come up. The Kubernetes controllers, the Nginx controllers, ingress controllers must have come up, and it started serving traffic. Similarly, it's run through our tests about getting to Google and not getting to Cloudflare. See, we got 100% packet loss somewhere in here. There we go. And all our tests ran, and it's undeployed all our infrastructure, so it's cleaned up after ourselves. Not as big an issue with Kubernetes, but if that was, running infrastructure in AWS, that saved us some money, which is really cool. So what we've looked at there is a few different stages where we've converged our code with the outside world. So we've said, please take us from the state we're in currently to where we want to be. So we make sure the Helm charts are installed, make sure my service is running. We've seen that we can run verify on single commands. And we've seen that we can run a full test sequence, which runs our linting, does a destroy, converge, verifies, does some idempotency checks, and destroys again. what I'm trying to show here is this was basically my dev loop for every change that I ever made. When starting, particularly on a feature, if it's on a module or a service that already exists, I'd converge my test code, which would spin up some infrastructure in a sandbox environment. I'd verify that everything was good. Hopefully all the tests pass and nothing's broken since someone's last touched this. I'd write some tests, verify that they work. They'll likely fail the first time I run them. At that point, particularly if I'm working on something that's reasonably complex and I don't know exactly how I should automate this, how I should write the infrastructure as code for this, I'd probably make these changes by hand. So I might run a kubectl apply, I might SSH into a server and make a change by hand, at which point I can re-verify and test that my change has worked and that my functionality is now behaving in the way that I want it to, which is great. But now I need to, that change that I've made manually, I need to write back into my IaC, which I can do, and I rerun a converge, and then I can re-verify again. I may or may not do a destroy in between making my changes and automating my changes. It really just depends on whether or not I can bring the state back, or I've already gone too far with my infrastructure that it's basically broken. I need to start again. Getting into a really tight converge, verify, change, verify loop was key to making this work, right? We got a really nice test harness and a developer experience if we could do that. And over time, I think everyone in the team kind of got used to how you can write your code and the ordering of things that kind of lets that happens. So that's kind of cool. We've looked here in these tests at how we could use kubectl and Helm with TerraTest. I've said a lot about Terraform because we use that an awful lot. So we could take a little look that it's not a one-trick pony, TerraTest, and really not much changes depending on the tool that we're using to actually deploy infrastructure or services. So here's some examples of the changes we might need to make to write some functional tests in Terraform rather than with Helm. So you see, we still have an apply method, but now rather than doing a Helm install, we might do a Terraform init and apply, right? This doesn't look massively different from the code before. Similarly, if you're testing a HTTP service, your code probably doesn't change at all. You're just making a HTTP request. It might be if you're spinning up, say, an EC2 instance with Terraform, you want to check that some commands are run on there. So you might use something like the SSH package to run an SSH check, as opposed to running the kubectl run to check that you can get out to Google DNS, for example. Similarly, if you're building Docker images, you'd maybe check that works by running a Docker build and then running your container. Exactly the same sort of thing, where with TerraTest, we can say, do a Docker build of this Docker file, and then run it and check that whatever script is its entry point, or in this case, I'm just catting out file that should be in there and check that that's all correct and expected. So again, same sort of test that you would probably do by hand, just written in an automated way. The benefits of automating this was really that we could start to pipeline them, and that it removed the knowledge from people's heads that we saw. It was mine, the QAs knew how to test these services, but nothing was really written down, or if it was written down, it was stale. Whereas this way, we've got sort of a living document about these are the tests that we can run. So from a pipeline point of view, on our CI servers, we ran static analysis. That was really fast. We then move on to a stage which we called sandbox, and that was a real, in our case, we were working on AWS. So that was we'd run it out of CI, it was GitLab in this instance. It would run those functional tests, which deploys real infrastructure into an AWS account, tests it all, and tears it down. And as I mentioned, almost top of the talk, we missed a few things. So it turns out that test loop where the tests clean up after themselves is great, and it works 99% of the time. If you happen to lose a GitLab runner, or if there's some intermittent problem on doing the destroy, you leave things left over, and in our case, we didn't notice. So there's a lot of tools out there. The one that we used is called Cloud Nuke, and that basically ran daily, which just looked in this account, found any infrastructure that was left over, and would completely destroy it. That worked really well. It saved us on having out control costs. It's just really important that if you're going to run something like Cloud Nuke, you need to deploy the infrastructure and run all your functional tests in an account which is completely away from any real infrastructure that you care about, because it will run, it will work if it has the permissions to do so. So you got to really keep it off to the side and make sure you don't accidentally misconfigure anything and point at a dev environment. So what do we do once we've got a module that we think is good to go, or a service that we think is good to go? We've got some changes. Once we've seen our functional test pass, that was the point in time where we could version that module or service and say, we know that this performs the functions that we want it to do. It should be good to go. We now need to deploy it into dev, which is normally our next environment up. The problem we had with dev, particularly working on a platform team, is we, being platform developers providing services to other teams, any environment that had other teams dependent on it, we kind of have to treat like prod, right? If we deploy a change into a dev environment, say on an AKS cluster, and we totally break the way that the nodes work and no one's pods start coming up, as much as end users who are consuming the services from outside the companies aren't effective because it's a dev environment, every dev team who's reliant on that cluster is now blocked because they've got work that they want to get on with. They don't want us to push any broken changes into there. And that was a big difficulty for us, which is why we kind of felt like we needed something in the middle of here. And we definitely needed to verify changes really quickly once they went into dev. Which brings me on to smoke tests. So for a lot of the services that we're deploying, they were multi-tenant, which actually meant we could run functional tests in the dev environment as a test tenant, because we're already strongly isolated from everyone else. We couldn't do that everywhere. So we needed a way, and we couldn't run necessarily all of our functional tests because it would potentially, some of those tests might perform risky actions. They might delete data. One example that comes to mind immediately was when we were testing somehow certain types of DNS resolution, how a server should behave when DNS resolution is failing. So we checked, we changed some URLs to be total nonsense. We got a bunch of messages back from cybersecurity saying, this looks like you've got some malware in there because it's trying to resolve these really funky URLs, which doesn't happen if we run it out in our sandbox. So what we identified was, we tried to identify a subset of tests which could be considered safe, which is what we would call our smoke tests. And we can invoke them whenever we did a deployment, both on the component we deployed and maybe the components surrounding it if we felt like it was particularly risky. What we realized after doing this is, whenever we were running these smoke tests and we were seeing, hopefully, them pass most of the time, that information is really interesting when you're doing a deployment. It's also interesting all the time, right? And we realized after a couple of months, really smoke tests should just be monitoring. We should check this all of the time. And we got rid of them for the most part and just moved it into our monitoring stack. So when we were doing deployments, we could look at, in our case, it was AWS CloudWatch, to see how the services were performing. And we saw a slight change in what did we see a change in? We saw a slight change in how we were doing our deployments and how people were talking about our deployments. So from our dashboards in CloudWatch, everything looked good. And yet we would have some messages back saying, oh, I think something's wrong with environment X from the development team. And then almost as soon as they've said that, we'd go and look and it had gone, right? We had these sort of highs and bugs that came and went. And I think the problem that we had with that was, if you rely purely on your monitoring, where in our case, we're pushing metrics to CloudWatch, there is an interval in there, and maybe we're running probes to see that DNS resolution is always working, or maybe we're, you know, pinging HTTP services like with readiness probes and what have you. But there are periods in between those intervals where something could be wrong and they could be critical. So what we found was relying purely on monitoring wasn't right, and having a completely separate set of smoke tests wasn't really right. So we tried to change things on its head, turn things on its head, so that we could have it in such a way that our monitoring would run these little smoke tests all the time and ship their results out. And, you know, that way we could alert on them out of CloudWatch. But also we wanted to have a way that we could invoke the tests at times that we knew were interesting for particular bits of infrastructure. So I'm about to turn off the server. Tell me the results of all its smoke tests right now, and tell me that of the service, and tell me the other servers that are running. What that found was, when we wrote those checks in the right way, a lot of deployments that we believed to have been zero downtime were actually very near zero, but not zero downtime. And being able to have your monitoring system look at these tests, but also your own pipeline be able to trigger them exactly when it needs to, was really what made the big difference for us, where we were able to see much more clearly and run the checks at intervals where we knew they were most likely for a problem, rather than it being missed and just being an amalgamation of, you know, all the data that we've got about the environment at that time, which is what we were seeing in our monitoring, right? It was a bit too fuzzy. So our pipelines ended up looking like this. Before a PR could go in, we'd run static analysis on it, quick and easy. Once we'd done a merge, or potentially ahead of the merge, depending on the team, we'd run our functional tests, which are really standing up, you know, our infrastructure, really running tests against it, tearing it all down once it had done. We're happy that this change is ready to go from our end. Then we deploy up through the stack with our smoke tests, and we, because of all the tests that we were now doing functionally, and that we were happy that we really did have zero downtime deployments in dev and pre-prod and prod, over time we became much more confident in delivering those changes. So I will quickly start to wrap up, because I have really run on and I want to leave time for some questions. Quickly run through some benefits that we saw of moving this testing from a very manual process into the sort of automation that you've seen here. A lot of the benefits we expected, and we did see them. So much lower lead time and cycle times when we were making changes. I think you could measure that in days comfortably. So that was a big win on how quickly we were able to deliver changes. Similarly, as we were delivering those changes, we had far fewer failed deployments, and we were deploying more frequently, which is great because you kind of need all three of those things. You know, there's no point in deploying more frequently if the number of failures is the same or going up. You're just delivering more rubbish. So that was really good to see, and we did see it, and it was something that we expected to happen. More time for operational acceptance tests. So our QAs would often be really busy. You know, we'd have in a team normally 4 or 5 engineers all working on features, and often one QA who felt like they needed to be the you know, the guardian to stop bad changes or slight bugs getting through. They'd be totally swamped. Whereas once we'd moved these to be more automated and kind of shift the ownership left, so that the engineers could be writing a lot more of the tests, it freed our QAs up to be able to really think about the more intricate problems that you could get, and how do we recover? How do we make sure we don't get any data loss? Can we run? What happens if we lose a whole availability zone? Right, they had a lot more time to think about that, which was great. We also got a lot of, quite late in the day, you know, pen test reports over compliance issues about, you know, you need to have this setting set. You've accidentally got TLS 1.1 enabled. Static analysis was the big thing that just kind of wiped 90% of those away. We had a few unexpected benefits, which some of the big TDD advocates in the room would say, well, yeah, of course you could have expected that, but it wasn't the reason we went down this road. But automating the tests and having engineers think about the whole testing ecosystem, particularly with that test first approach, really did lead us to having much cleaner code. when you were forced to write all of those tests up front, you could quite easily see now that some of the tests you're writing are kind of sticking out like a sore thumb, like it shouldn't be part of this module. Why am I looking at functionality A when this module is all about B, which we had a lot of problems with. And it made our code much cleaner. We kind of split modules down a lot more in and combine and compose them up into a working service rather than having sort of everything in one. That was really useful. The other really big benefit, particularly for our base images, so where we're producing AMIs and Docker images, was and where we missed that sort of spec and where we were potentially introducing breaking changes because we didn't know people were dependent on certain things. The tests act as a little bit of a spec of this is the behavior that we think should be supported and should work, and we're committed to making sure it works because we've got tests for them, and we could publicize that much more easily to our consumers. So by way of an example, we had a Docker image which it was a node base image. It was used by a fair few teams. It turned out it had JQ installed in there, I think because of some report that we generated once. We removed that and broke 10 teams pipelines because we didn't think anyone was using JQ. Once we'd moved into this world where we could say, here are the tests, here's the test report of them all passing, this is the behavior that's expected, it was a lot easier for teams to understand what they should expect to work and what are just side effects. And that really started to close the loop on getting feedback from those teams, particularly from development teams, which ended up doing we were able to do a little bit of pack testing or contract testing, where someone would come along and say, hey, look, this thing is working today, but I see you don't have a test for it. Can I add one? I would say 50% of the time we'd say, yes, that was meant to work. We've probably missed a bit of test coverage. 50% of the time we probably said, we've missed that you shouldn't be allowed to do this thing. Please don't depend on it. We now know to go and add a test to say that shouldn't work. And get in touch with people who are using the service to tell them that maybe this is going to be a breaking change. Even though nothing to do with the actual contract of consuming a Docker container or a Terraform module has changed, right? We've changed the functionality of it. That being said, it wasn't that you do lose some things. So what we knew would come as a cost would be the complexity in writing and maintaining the tests. That is you've given yourself a burden there to keep these things up to date and working. I think it was worthwhile in our case, but it's definitely something to consider. One thing that we didn't expect that would cause a problem, and you could argue whether this is a problem or not, but it was definitely an unexpected drawback for me, was we lost the intimate knowledge of how to test a service, right? We got pretty good at writing these tests. We got writing them pretty quick, which meant it was no longer in our heads. Now that's a good thing, because that's probably why we could go faster. Because we didn't need to know the intricate details of how this service works. The one example of where that actually bit us was we had a problem in production, reasonably serious problem. We couldn't tell what was going on. Some service wasn't behaving in the way that we expected it to. And we got to the point where it was a serious incident. We needed to SSH on some of the nodes. We're in a break glass situation. So we did. We started looking around, running some diagnostics. And then our SSH session got disconnected. Oh, that's weird. Start again. And then our SSH session got disconnected again, which led us to believe that this was part of the problem that we were trying to solve, right? So we were looking into that for a good probably 10 or 15 minutes when we had a production incident. It turns out, unbeknownst to us, not part of our code, not part of our service, some of the default session timeouts had changed. So when we used to be able to connect it for 15 minutes at a time and be uninteractive, it was now like 3 minutes. Had we have been testing by hand like we always used to, we'd have known that, and we'd have either asked for the settings to be changed, or we'd have just known and we didn't go down, we wouldn't have gone down this rabbit hole. And I think that's something that we really did lose, which is just this looks a bit unusual. And our QAs were particularly good at that, right? They not only would they go and test, does this new feature work? They'd be looking in and around and saying, I'm expecting this to happen, I'm expecting that to happen. This looks a bit strange. And you lose that as soon as you automate your tests. So there are drawbacks, but I think the benefits overall were way worth it. Tony, I see you've turned your camera on. Are you ready for me to shut up? Awesome, cool. Right, well, I'm on the last page anyway, so we're almost there. Key takeaways. I think the key around writing any of these tests is pragmatism. You will probably not be able to automate everything, and it's okay to stop. Similarly, things that you have automated, and I reckon this could be 10% of the test that we wrote, you'll find out that it took you way too long and they turn out to be flaky over time. The only way that we could see to fix that was just delete them. You know, it's not worth the overhead of trying to nurse these tests into a working state, and they need too much attention to be worthwhile, so just get rid of them. Turn on static analysis if you're not already doing it. Just pick a tool and start using it. It will catch things, and it's almost free. When you're writing tests, test the functionality of your service, not the settings in a console or in a particular controller. Tests are going to need to handle intermittent problems and asynchronicity in being deployed. TerraTest has some really cool helper methods for that. But you need to handle that from step one. Treat tests like a contract with your customers, your consumers. So be really clear about, these are the things we expect to work, these are the things that we don't expect to work, and be willing to have feedback on that, because we found it was really helpful and almost a document to sort of communicate around. Measuring whether it's actually helping for you is a big thing. So we were lucky enough to have a delivery lead who was keeping a really close eye on this, and we were in parallel working on getting DORA metrics set up. So 4 keys, which were, having a look at how quickly we were deploying things, how often we were, how often they were working, which made it really easy to sell the time we were spending on this and know that we were going in the right direction, because all the numbers were getting better. I think if we didn't have that, it's really hard to know whether you're improving or not if you can't measure those things. Yeah, and other than that, we mentioned briefly about the smoke tests and the monitoring working hand in hand. You've got to work really hard to stop yourself having functional tests over a larger and larger and larger scope, where they get flakier and harder, and you end up with a huge end-to-end test suite, which you think covers all of your scenarios, but it's really difficult to run and it takes a really long time. We ended up probably going a little bit too far down that road, and luckily we were able to stop ourselves and pull ourselves back and go, no, this is a monitoring concern now, not a test concern. But as I say, even with that, pragmatism's the key, right? Just you've got to feel it out, measure whether or not you're getting better or not, and that should be a guide on knowing where to stop. And I think that I should probably go for some questions.
Talk about perfect timing. That was exactly on the hour. Just conscious of time, so we might take 1 or 2 questions, and if we then we might actually just invite you, if you've got actually further details that you want, just reach out. Grab Nick on LinkedIn. There's another page with our email addresses. I'll pop up in a second. Joining next month, we have another expert talk. What we try and do is we flip between a business transformation topic, and then we go deep dive into tech. Next month, we're going back into the transformation space. There's an interesting topic around how do we move away from measuring transformations based on return on investment, and how quickly we innovate to more, how do we actually inspire people, and how we're measuring that. So that'll be a good topic if you're interested in that. We also have, I just should have put a link in here, there's actually a digital platforms playbook. So we open source a lot of the thought leadership and work, and that's actually available on the Equal Expert site if you want to just log in and search for it there. Actually, let's go 1 or 2 questions. If you need to leave, hop off, people, but let's throw, IJ, you've had a lot of questions and comments through this. So the first, hit your 2. So Nick, can you see the Q&A panel up there?
Yeah, I've got it on my other screen here.
So being a government project, it's impossible not to have the security folk poking between dev and ops. So was the smoke test your sec part, or of the DevSecOps?
That's a good question. I think probably a mixture of the static analysis checks, because it makes security people happy when you get to a point at, here's a check that someone came up with, and it's got a CVE almost number against it saying it's checked for that, was a nice thing to hand over to the security team. And yeah, I think the smoke test played a part in that. I think the smoke tests were probably more around availability and our services up and running. Should we roll back automatically, or should we roll back right now? Is everything still healthy? I feel like we probably didn't get as far with automating all of the security parts of the stack as we could have done. I think most of the low-hanging fruit with helping out with the security people, of which I like that you're up DevSecOps, because that's all of us, right? Were more the static analysis tests, where if we're building a Docker container, we can run Trivy against it or something equivalent, where it's going to throw up, these are the CVEs, here are some really common misconfigurations. We, on occasion, had, as you say, particularly in a government department, some fairly stringent and somewhat esoteric requirements on how things were configured. Being able to write, particularly if you're using something like Terraform, being able to write a checkoff test for specifically that configuration was really useful and really quick. And the security folks were normally okay in reading. They're certainly okay in reading the report. They were normally okay with reading bits of the code to check that they were happy that it's checking what they were after. So for us, I think it was more the static analysis which helped with the security side.
Cool. All right, and last one, we'll just hit this one. Where was the scale? So many tests when you're covering Helm, Docker, Kubernetes and stuff. I think you covered this probably as a summary in your last slide, is don't try and automate everything. Any tips there for IJ?
What's this? Where was the scale? If Helm Docker takes so many tests, how to write functional tests for other rarely used services. Right, interesting. So we didn't get a great deal into this. So if it was rarely used services, but you were testing them from a functional point of view, we obviously, in that flow chart of from CI to prod, we ran our functional tests quite far on the left, right, just after CI. If we're talking about services which you're deploying, so API management, I guess backup and restore would come into this, SQL clusters, we would write functional tests for the modules that deployed, say, let's use an example for API management. Let's say it's APIM in Azure. We would likely have a Terraform module which set up that API management, a bunch of APIs, few products, and maybe a test subscription in a sandbox account. We'd make HTTP requests against those products and APIs, check that it all worked properly. Then we'd be ready to deploy them into dev. Probably similar for things like backups and DR failover. I guess the bit where it changes, and in the way in which we'd say, if you were testing a particular SQL server, we would use, let's say it's Microsoft SQL Server, we'd use a Golang Microsoft SQL SDK to connect to the database and issue database queries against it and make sure it worked in the way we'd expect it to. Where I think we'd have drawn the line on we'll test this by hand is if we had a service and we wanted to test holistically, how do we do a failover? What happens if we lose an AZ? What happens if we lose a region? Those sorts of disaster recovery, what we put into operational acceptance testing in our speak, we'd left all of that manual. I think people having eyes on glass and knowing what they've killed when was as good as we were going to get in anywhere near term. There's an argument to be made for, if you've got really good monitoring, turning some sort of chaos type testing on would be doable. We were nowhere near being able to do that. That was, yeah, I should say it's only part of our pragmatism of, we're not going to automate this. Let's keep doing that by hand.
Alrighty, thanks, Nick. That was a lot of coverage, man. Thank you for that. We are going to wrap up for timing reasons because we're already a little bit past the hour. If you have found this interesting and you want to share it with colleagues, The video recording will be up on the website in a few days. If you're having problems with your own digital platform and you're hitting some of these issues, please feel free to contact us. We're happy to have a chat and see how we can help. Massive thank you to you, Nick, and thank you everyone for joining us tonight. Have a great day, night, depending on where you are joining us from, and we hope to see you at one of our future talks. Take care.